Experiment of low pass filter design. Dear students, now I am going to explain the active filter design for high pass filter. So we already know what is low pass filter and how we are going to design. So both are slightly similar. So instead of placing a resistor, we need to place the capacitor values. Instead of placing the capacitor, we need to place the resistor values. The small similar small changes that will be happen between high pass filter and low pass filter circuit connection. So now I am going to connect the circuit based upon the circuit diagram for the high pass filter, but components what we are using for the low pass filter, the same components we are using for the high pass filter design. Now I am going to start the circuit connection. I am taking the circuit board and I place the IC MUA 741 to the circuit board. So I am taking the 5.6 kilo ohm resistor and I place this as the feedback between the pin number 2 and the pin number 6. So this is pin number 1 and 2, this is pin number 2, pin number 6, this is 5 and 6, this is the pin number 6. I made this as a feedback. Now I am going to connect the resistor 10 kilo ohm to pin number 2 to ground. So resistor number 10 kilo ohm that will be connected to pin number 2 and pin number 2 to the ground I connected. So this is the ground connection. And 1.6 kilo ohm resistor I am taking. So I will connect the 1.6 kilo ohm resistor to pin number 3 to ground. So this is pin number 3 and I made this pin number 3 to ground with 1.6 kilo ohm resistor. I am taking two capacitors, one capacitor that will be connected to pin number 3 to somewhere in the circuit board. So this is pin number 3 and I connected somewhere in the circuit board. After that I am taking another capacitor. I will connect this one to the junction of this capacitor to somewhere in the circuit board, make it as a series to the circuit. After that I am taking 1.6 kilo ohm resistor and I made the 1.6 kilo ohm resistor that will be connected to the junction of these two capacitor and the pin number 6 like this. I am taking the patch card to connect the input for the circuit. So I connected the patch card and I am taking the wire to connect the positive terminal of the circuit to the junction of the capacitor here, and the negative I made to ground. This is the ground connection I made. Now I am going to connect the DC regulated power supply. So positive end will be given to pin number 7. This is pin number 5, 6 and this is 7, and the negative end I want to make to ground. The negative end I will put it into ground. Here another terminal I am taking the positive, I need to put it into ground. This positive I will made to ground. The negative end that will be given to the pin number 4. This negative end I will given to the pin number 4. This is pin number 4. This pin number 4. Now I am going to connect the output terminals to see the input. I am connecting the patch card to here, the terminal 1. So I am taking one wire to positive connection. I will place this to input junction and the negative terminal I place to ground. And another patch cord I am taking to connect the output terminal at the terminal 2. So positive end I will be connected to the pin number 6. So this is pin number 6, and the negative terminal I am going to connect to ground like this. So this completes the circuit connection of a high pass filter design for the frequency of 1 kilohertz. So now I am going to switch on the signal generator, digital oscilloscope, and DC regulated dual power supply. I want to set this DC regulated power supply to 12 volt in both the terminals. This side also I need to set to 12 volt. I want to set the frequency. We are designing this for 1 kilohertz frequency cutoff range. So approximately we can get around some 1.4 kilohertz as a critical frequency in the circuit. So now I'm going to set this frequency first. So frequency to some 100 hertz I will give first. Frequency some 100 hertz. 100 hertz I will give. Switch on the input signal. Now you can see by using auto set, this is the input signal we are getting. So but we are not getting any output signal. So you can raise this to this frequency to some 200, a slight variations that will give an output, increase to some 400, 500. So we can get a small signal there. So later on I'm going to turn off the input signal. So I'm using only the output signal as a reference. This is the output signal. So further I increase this to some 1 kilohertz directly. So till that it will give an incremented version of the output in the amplitude, you see. So for example, if you say some 700 hertz, the output will be 2 volt peak to peak. So if you increment to 800 hertz, it will give some 2.2 volt peak to peak. 900 hertz, 2.3 volt peak to peak. 1 kilohertz. So for the 1 kilohertz, it will give some 3.2 volt peak to peak. So later on I will increment to 1.1. So it gives 2.4 volt peak to peak. 1.2, it will give 1, 2, 3, 4 volt peak to peak. So I'm going to adjust the scale like this. 4 volt peak to peak. I further incremented to 1.3, 4.1 volt peak to peak. 1.4, it will give 4.2 volt peak to peak. Further I incremented to 1.5, 4.3 volt is the peak to peak. 1.6 also 4 volt, 4.2 volt is the peak to peak. 1, 2, 3, 4, 4.1, 2, 3, 4. 4.4 is the peak to peak. Again you incremented to some 1.6, 1.7, 4.4 is the peak to peak. 1.7, 1.8, 1.9 also you can get the same. Further you incremented like this, it will give a constant value. So later on it will start to give a constant value. So at the output terminal, this is the constants we are expected. Now it start to increases to some other voltages. Now it will be raised to 1, 2, 3, 4, 5, 6, 6 volt peak to peak after 5.8. So we don't go to that much of design. We are using only for 1 kilohertz frequency circuit design. So in that, the critical frequency of this high pass filter is 1.5 kilohertz. This completes the experiment of high pass filter design for frequency of 1 kilohertz. Now I am going to connect the circuit based upon the circuit diagram of band pass active filter design.